All right, great. We'll get started. A few more stragglers coming in. Hello and welcome. Thank you all for coming to Couchbase Connect Europe. Thank you all especially for coming to this presentation. My name is Perry Krug. I'm a principal architect with Couchbase based out of our London office. And today we're going to go through, or I'm going to go through an overview of the Couchbase Data Platform. From a technical perspective, we're going to have a exciting demo by my colleagues from the Manchester office, and then we'll have some Q&A time with our CTO Ravi towards the end. So let's get in. Some of this material you will have seen during the earlier sessions today. I'll go through it relatively quickly, but just helps frame the context of what we're talking about. It should be well understood that everything around us is changing, this idea of a digital transformation. But what's really changing the most is the volume and variety of interactions that all of our customers are having with our platforms. If we look across a couple of the different industries, where once you would go to a travel agent, he or she would look up a couple flight options, give you the best one, you would book it and you'd be done. The relatively close ratio of the looking to the booking. Same thing with shopping. You might go into a store, God forbid, or actually look online for a couple different products and choose to buy them right there. But what has happened over the last 5 or 10 years or so is a massive explosion in the first half of those equations. So according to some statistics that Amadeus has been giving us, they're now seeing hundreds of thousands of looks to a single book. And that means they, as a platform, as an application, are needing to support a much higher degree of interactions before they get the actual kind of financial transaction. And for all of those interactions, customers are expecting them to be feature-rich, personalized, fast, available, stable. They're expecting them to work offline. And if they don't work, and we all know this on any sort of app that rolls out a new feature or a new application, that first time you get an error message or the first time there's a little spinning circle that doesn't work, you're very, very unlikely to try that again. So it has to work. It has to always work. And as we saw earlier today, at least 90% of customers are going to go to somebody else, go to a competitor, or not come back to your business if you can't supply that experience. So here we are today saying that in order to deliver those experiences, deliver those engagements, we need to talk about a new database, a new way of bringing the data to and from the users. Why? Because relational databases are not fit for that purpose. They were designed in a world where a few hundred, maybe 1,000 users were interacting with a monolithic application, and the expectation of those users was that the application would sometimes be available, it would have distinct periods of downtime, and it would be changing maybe once a year, maybe twice a year. Fast forward to today, and even the smallest of applications are expected to reach thousands, tens of thousands, millions of users. They're expected to be available all the time, and they're expected to evolve and change many times a year, many times a month, in some cases many times a day. New features are rolling out, right? Facebook, Google, and Amazon have all conditioned us to expect that sort of experience from everything else that we have in our lives. And so as Peter was talking earlier, every time a organization brings out a new level of experience, that raises the bar for everyone else. So relational databases weren't built for that kind of application, development, production, scaling. They have challenges with agility and flexibility because of the rigid schema and underlying implementation of that. The performance is very, very challenging to manage at any sort of scale, either extremely expensive because of the hardware requirements or extremely complicated in terms of replication and geo replication and whatnot. And then from a management perspective, managing the sharding, managing managing the caching layers, managing the changing of schemas is all extra complicated with a relational database, and not to mention one that you're trying to keep online all the time. So where we are today and what Couchbase has realized over the years is that relational databases, okay, we agree, were not built for these types of applications. But they do what they do very well, and they need to continue doing that. But there's a new class of workload, a new class of application, systems of engagement that need a database that was designed for them. And that's where Couchbase comes in as an engagement database. There's no thought that relational databases are going to go away entirely. You still need to support transactionality. You still need to support the actual movement of money from one place to another. But all of the meta traffic, all of the looks and the searches and the interactions getting to that monetary transaction, those things are not well served by a relational database. So if we look at the Couchbase Data Platform, we go back to those three kind of key pillars. We're talking about unmatched agility and flexibility. So that's both at a development level from a data modeling and support for JSON. It's also at an operational level, being able to scale and change topologies, deploy onto a variety of different platforms. Performance doesn't just mean raw speed. There are plenty of very fast technologies out there, but being able to provide that speed consistently, being able to provide it during the course of maintenance or failures or scaling. So that's what we talk about performance at any scale. And then ability to manage the platform. Yes, it is a distributed database. That doesn't mean it should be complicated and hard to manage. That doesn't mean that you shouldn't be able to replicate geographically or within a data center. And just for some last kind of marketing discussion, if we look at the IDC report that Peter referenced earlier today, from a flexibility perspective, our customers are seeing at least 19% kind of faster development cycles, getting a feature, even a small feature, out to market that much faster. Being able to provide 40% faster response times. We all know that a faster website, a faster app means your customers are going to feel more comfortable using it and continue to use it more. And then 37% more efficient database management. Again, those things, complicated tasks of sharding, replication, upgrades, all of those are very, very easy with Couchbase, and we're going to see kind of why later on. And all of that culminates into what was measured as a 274% return on investment from our customers that are using Couchbase to build their digital applications. Okay, so that's enough of the marketing and statistics. Let's get into some of the more technical details of how Couchbase has come to be. We started with a few kind of core principles. And the lifetime of the product has closely mirrored the lifetime of our customers and their needs. So starting off with very simple caching layers and key value storage, adding support for JSON, for more complex querying and indexing, adding support for full text search and mobile synchronization, soon to be and developer preview, support for real-time analytics. All of this built on a memory-first architecture designed for clustering and auto-sharding from the start. So a number of other technologies started off as single node databases and have added on replication and clustering as the years have gone on. Couchbase started that way from the very beginning. We take an asynchronous approach to everything we do, and this allows the software to continue performing even as more and more load is put on it. It allows the behavior to remain consistent and also gives us the ability to have tunable consistency, tunable trade-offs of performance by taking asynchronous and wrapping it in a kind of synchronous model gives us the benefit of both worlds, and you, the application, the ability to trade that on and off. Obviously, being heavily focused and supporting JSON gives us a wide degree of flexibility in terms of data model and evolving of schema. And then one of the interesting innovations, and we'll talk about this much more later on, is the ability to scale the workloads within a database independently. We've taken a very microservices approach to how a database should be deployed, which gives us much greater degrees of flexibility and performance and scale. So this picture you may have seen earlier is what we call the Couchbase Data Platform. The architecture here, you see in the middle there, that's that core database engine, the core key value engine that is elastically scalable, memory first, and on top of that, then we've added query and search, mobile synchronization, analytics, and more capabilities to come in the future. Across the top, a unified programming language interface. This comes both from our SDK that we provide that gives you a single point of entry into any Couchbase cluster, and also our reliance on SQL for our query language that we'll talk about a little bit later on as well. And then on the left, security is paramount to any sort of database discussion. Couchbase has end-to-end security, both for out at the edge, across the network, and down to the disk. And where are we? To the right, integration with the broader SQL and big data ecosystems. Couchbase, we know that we are not the only technology in your stack. We know that playing well with technologies like Kafka and Spark and Hadoop and the other big data technologies is an important part of building out an entire application. And so Couchbase makes it easy to either ingest or send data to those. And then finally, across all of this, Couchbase is supported across multiple infrastructures. So physical hardware, virtualized, containerized, and any of the public or private clouds. Another concept that we talk a lot about is this idea of full stack management. And so this is kind of where Couchbase you may see Couchbase fitting into your environment. You may be writing an application in C or .NET or Java or Node.js, but it's your application. It might be running on an iPhone or an Android device. But no matter what application you're developing, you have three kind of basic tiers to contend with. You have the client tier, which is either the browser or the device that you are making your application available on. The middle tier, where a lot of business logic and services exists, and the database tier, where your actual storage resides. For many years, and even continuing today, a large majority of our customers develop their whole application on top of Couchbase Server. That's the scalable document database, and it's your job as an application developer to take care of the rest. Right? You have an SDK that interacts with the database, and you worry about moving the data from the database layer through your middleware and onto the client. But there's a little bit more that Couchbase has to offer. And the middle layer, this layer is also where you have a lot of the integrations, both replication and Kafka, Hadoop, Spark, monitoring, ETL tools out of the database layer. But at the middle tier, we have something called Couchbase Sync Gateway. And this also provides data access patterns without actually storing the data. So whereas Couchbase Server provides an API through an SDK, Couchbase Sync Gateway provides a REST API, batch, and stream APIs so that you don't have to manage that yourself. You configure this to provide those as data services. And then most commonly, this can act by itself. Most commonly, our customers are using it with Couchbase Lite all the way out at the client tier. And Couchbase Lite is an embedded NoSQL database that gives you full CRUD, query, search, replication out on the device itself, much more than just a caching layer that you might be familiar with, but actually an embedded database that supports fully offline functionality. And then wrapped all around this is a pluggable security layer. So we have security with role-based and pluggable authentication, authorization, and encryption all the way from the edge back into the data center. And so we're going to start looking at some of the pieces of how this actually works and how you might interact with it. We're going to focus mostly on Couchbase Server for today's discussion. There are other sessions and a lot more kind of discussion to be had about the other layers. Taking a quick look at some of the new kind of data management landscape and where Couchbase fits in. You see a variety of technologies all in this broader ecosystem. I'm not going to go through all of the layers individually, but where you see Couchbase's kind of sweet spot and core capabilities in this user-serving, in-memory data serving layer, either taking data in from your users and or serving it out. Another way of looking at that is in a kind of Lambda architecture layout where you have data coming in from a variety of sources, whether it's your application or services that you're pulling in from. And you have it processing through a batch layer across the top and a real-time streaming layer across the bottom, and then eventually being served either back to your application or onto another application that is consuming it. You can see some of the common technologies like Hadoop and Kafka and Spark existing at their own layers. And then Couchbase comes in for either the real-time streaming layer, taking data in as an ingestion layer, and or serving it out. And so many of our customers are using Couchbase in all of these places as a kind of cyclical database, or have chosen only one or more places depending on where they get the most value from. So I hope that gives you maybe a very fast, but an overview of where Couchbase fits into these environments, the types of applications and the types of workloads that we are primarily focused on. We're now going to go a little bit deeper into the technology. Two of the key principles that that I mentioned earlier and that we have tirelessly focused on is the ability to develop with agility and operate at any scale. And to be able to do those two together is really what all of our applications and our customers are demanding of us, and where they are finding other technologies not suitable, either relational databases or some of the other NoSQL vendors. And so there's a variety of features that we're going to go through that Couchbase has developed and brought out in support of these two kind of core pillars. So first off, development. Developing with agility means being able to bring your application features out to market faster, incrementally, so that you don't have to build a monolithic application and then deliver it all at once. You deliver it in pieces, and you can build and expand upon those as you gain more and more feedback. And all of that requires a very flexible schema or data model underneath. Couchbase and many others have chosen JSON to be that data model. Couchbase also supports any non-JSON data in binary form, so storing blobs in the database, but the vast majority of our functionality is focused around using a JSON data model. We're going to talk a little bit more about how this operates with our query language and data modeling in the later sections. But before we do, just some kind of key concepts that we're going to refer back to. Data in Couchbase has a key, a document ID, and a value. And that value can be anything up to 20 megabytes. The vast majority of cases, it's much, much smaller than that. The key can either be, this document or this item can either be key value pairs, so storing strings or integers or serialized objects. And in that case, Couchbase operates and exposes itself to you as a key value store, storing those opaque blobs. You can also store JSON documents. And the nice thing about Couchbase, you can store these side by side in the same database. And so when you have kind of a mix of data, you don't have to worry about segregating it. You can keep it side by side. And even as key value, you still have quite a bit of querying and indexing because the key name itself is recognizable to Couchbase. And so you can do range queries and searches off of that. When we see how all of these items or documents get displayed across a cluster, some of the terminology that we're going to use, a node is a single instance of Couchbase installed somewhere, be it in a container or in an Amazon instance or an Azure instance or a physical piece of hardware. Multiple nodes come together to form a cluster, and then a bucket is our word for a data database, a logical grouping of unique keys within a cluster, and you can have multiple buckets within a cluster. And then the documents themselves, those records, usually JSON, but don't have to be, are then distributed into the bucket. The keys need to be unique within a given bucket, but you can mix types. And so rather than think about a bucket like a table, think about a bucket like a database that's going to have multiple tables within it. So you may have your orders and your customers and your company documents all as separate document types, all within the same bucket, because that bucket is what's serving your customer order application. And then when you're coming to access Couchbase, there are a variety of tools, a variety of ways that you have to get access to the data. We'll talk about the kind of underlying architecture a little bit later on, but from an application point of view, all of these APIs and the protocols for accessing data are abstracted away into our SDK. So your application just has to embed the library of whatever language you are working with. You have a single instantiation of the cluster, and then you have a variety of APIs that you can access data with Couchbase and our software, abstracting the topology and the protocols and the ports and all of that away from you. So at one hand, you have your key value operations. This is when you know the primary key of the document that you're looking up, and you can build some or all of your application logic on top of that. That's also where we support MapReduce views, which are a way of aggregating data within Couchbase. There's also NCL queries. We're going to talk about NCL in just a minute, but this is our SQL-like query language that has been extended specifically for JSON. We then have full text search, and the difference we'll touch on a little bit, but the difference between query and search, query is really that structured query where you know what parts of a record you are looking to match. You have a rough idea of what you're expecting to get back. Search is what you might imagine much more of a Google-like search where I don't really know how to spell what I'm looking for, or I don't really know where it is within some free-form text. And I might want what I searched for, but I might also want a little bit more than that, or I might want a little bit less than that. And that requires a slightly different way of asking the question. So that's where query and search come together. And then we are building in, this is in developer preview now, but we're building in a real-time analytics layer. And you might be asking why a separate way of querying data. So our query interface and our NCL query engine for right now is designed for fairly high performance, high throughput transactional queries that are touching relatively small parts of the data, where you're using a well-defined index much in the same way you would a relational database. What we found was organizations also want to be able to do much longer running or relatively longer running ad hoc queries going over the whole or a larger portion of the data set and returning a much larger result set. Not something that you might put in the critical path of your user application, but certainly something that you need from a business intelligence and an analytics perspective. And so we are have created a separate query engine and service within Couchbase to provide those. That's in developer preview now, and will kind of walk along the path to beta and GA over the coming months and releases. So let's go into a couple of these in a little bit more detail. First, if we look at Couchbase querying, and when Couchbase we talk about querying, we separate that a little bit from our key value lookup or CRUD operations, where you know the primary key of the document. Querying for us is using our query language called NCL, in most cases using an index across the data to support that query, and then returning a result set back to the application. It could be one or more documents. If you're familiar with SQL, you're going to be familiar with NCL. This may look like a SQL query, but it's also a NCL query. At these fairly simple levels, the two syntaxes look exactly the same. So NCL has all that you would expect from DML, DQL, and DDL, being able to define indexes, being able to mutate data, being able to query it. But all of this is what SQL has and what we brought up parity with. But on top of JSON, there are some things that SQL is missing. And so if you imagine a JSON document of a nested hierarchy, maybe an array of nested objects, the SQL language doesn't have the words to describe that. There's no way of saying I want to access a field that's 4 layers down in each element of an array. And that's where we extended SQL to become Nickel. And so some of the things that we added, this idea of nest and unnest, which allows you to manipulate hierarchical objects within the query. And another common thing that we find with JSON, especially as your schema and your data model evolves, you might have one record of a certain type sitting right beside another record of a certain type, and there are different fields, because as you're adding fields or removing fields. And so we had to introduce this concept of missing. So whereas SQL, everything is in a very structured table and a value has to exist. It may be null, but it has to be there. Within JSON, it doesn't have to exist, and you need a way of expressing that. And so Couchbase with Nickel, we added the concept of missing so that I can say, give me all documents where this field doesn't even exist, or give me all these documents where the field does exist, knowing that there may be some where it doesn't. And so there's a couple more examples as you get into the language. We have great tutorials online, great training sessions. But to get started, it is SQL at its syntactical level. We also have indexes that you might define, whereas Nickel does support ad hoc queries. That's equivalent to a full database scan. And so for any sort of production environment, you want to define the right queries. The nice thing about Nickel that we've made sure to focus on, you can create an index on any level of the JSON. So any nested level, any arrays, you can create a point index on it, and that helps speed up the query dramatically rather than having to pull over large JSON objects and parse them on the application side. So one of the concepts that we get into quite a lot of conversations around data modeling and whether to be normalized or denormalized. A big challenge with kind of most NoSQL databases, is that they require a large degree of denormalization. They force you to denormalize everything, which ends up with not only data duplication and explosion, but also a struggle with consistency when you have to update one field or one piece of information that's shared by many, you have to update in all of those places. And on the other hand, relational databases force you into very, very strict normalization of data. And while that helps kind of keep data explosion down, it makes it very hard to expand your data set and your data model. With Couchbase, applications and your data model, you can choose a hybrid normalized and denormalized model. Wherever it makes sense. So if we look here, we have a typical kind of customer document. Sorry that it's grayed out a little bit here, but you might have, and this is an example of a denormalized data model where you have their credit card info included with their email address, included with their address and their first name and last name, right? In a relational database, this would be at least 3 or 4 tables, and you all know that your applications are many more than that. But Couchbase, because of JSON, we give you the ability to denormalize the data where it makes sense for you. But now let's say we wanted to start adding purchase orders for this customer. One option might be to duplicate all this information every single time. Right? That would be a very denormalized way of doing it. And we'd end up with not only data duplication, but the inability to change a field in one place and have it be consistent across all of them. Another approach might be to start embedding the purchase orders into this one document. And that may be simple enough to start out with, but it leads you to a document that is going to be growing uncontrollably, or at least unbounded. And that's going to introduce other performance and kind of data manipulation challenges. So what do you do in Couchbase? We create purchase order documents that link back to our customer document. And so you see here, we haven't duplicated any of the information. We've only put their individual purchase order information in each of those documents. And this field, customer ID, points us back to the customer document. This way we can read one or all of them and get a complete view, but we don't have to worry about changing the first name or last name of this customer and having to change it in tens or hundreds of other locations. Now, where the beauty of this all comes back around is with Nickel, we support joins. And so that's relatively rare amongst other NoSQL databases. But within a single nickel statement, you can join your purchase documents to your customer document and get back just the information that you're asking for. And so this query is saying, get all of the email addresses from the customer document, join it with all of the purchases and count them up, and then return that back to me grouped by the email address. And so this is relatively simple, but you can see the power that nickel provides you, whereas without that, your application would be doing a lot of back and forth trips to the database, allocating memory to handle each one of these documents, traversing the tree. Nickel allows you to push that down, push that processing down to the database layer. Okay. The last thing we'll talk about from a development perspective is our full text search. Whereas Nickel is based on SQL and is a very structured query language, full text search is a little bit more involved and has an API around it where you can specify all sorts of different parameters to the search that you're doing. If any of you have used Elasticsearch, the concepts are going to be very, very similar, but this is built into Couchbase, so you don't have a separate layer to manage. It was written by us from scratch with another open source project called believe that we developed and have an engine and then the corresponding client library for doing all sorts of full text manipulation, stemming and scoring and relevance-based matching. Okay, I think I'm doing pretty well on time. Let's move on to the operations side of things. So all of that development experience, one of the key benefits to remember with Couchbase is all that you have developed does not change no matter how you are deploying. So if you're running Couchbase on your laptop, if you're running it against a test cluster of VMs, whether you're deploying it to a 100-node cluster in the cloud, the behavior of the application doesn't change. So you don't need to re-architect the application, which allows you to get this separation of development concerns from operational concerns. Certainly those two are closely linked in the world, in the DevOps world, but you want to be able to make changes at an application level or make changes at the database level without having to synchronize those two or introduce any downtime. So let's talk just briefly about the architecture. We saw this earlier from an application point of view. Within Couchbase, we have introduced a few of these kind of key points. So every node is the same. Every node has the ability to run all of the workloads and all of the services. So there's no need to worry about separate layers for configuration, separate monitoring, things like masters or slaves, head nodes, config nodes, name nodes, all of that goes away. A Couchbase node is a Couchbase node, and all of its functionality is configured at runtime. Excuse me, the internals are broken up into what we call services. And this kind of roughly translates to the different workloads that a cluster might be performing. And we're going to talk about that a little bit later on. But in this context, they are separate processes, and they can be turned on or off per node at runtime. And then finally, there's a cluster manager running on every node. And this is the process that holds the cluster together. It manages startup and shutdown of processes, management of statistics, logging, all that sort of coordination. If we take a quick look at kind of the flow of data from an application into the database, you'll see that all of these services exist within a cluster. And as I mentioned before, there's no need for a load balancer or a proxy layer or a routing layer. The application itself, our intelligent SDK, manages all of the load balancing and all of the connectivity. So from an application perspective, you see a single point of connection into your cluster, but it may actually be spread across many nodes underneath. And yeah. So if we take a look at this picture, it may look like we're talking about one node with multiple services running in there. We can be, and that's possible. You can run all of your application on top of a single node of Couchbase, which is useful from a development perspective. But this may also be a cluster underneath where each of these services is deployed across one or more nodes in a distributed fashion. And that leads us into the idea of how do you scale a cluster of Couchbase. Historically, and with most database technologies, all of the workloads, be it storing data, querying data, indexing data, all the things that a database is being asked to do, historically have been spread across every node of a cluster. And that may be fine, and that may suit your needs. But what you start to find is that each of these workloads is doing slightly different things. Querying is more CPU intensive. Indexing likes to be consolidated to a few nodes rather than spread across an entire cluster. And so you want to be able to control that. And with Couchbase, we have this concept of multidimensional scaling, which allows within a single cluster to segregate those services, dedicate specific groups of nodes to each of them, and then scale them independently. And so you may want to provide more CPU power to your query nodes. You may want to provide more RAM to your indexing nodes. You may want to add more nodes to scale out your database, your data storage layer, all without changing the behavior and interaction of each of these pieces. And a very important part of this is the ability to change these topologies, adding nodes, removing nodes, upgrading the software, moving from one piece of hardware to another without ever taking the database down. And that's a really key part of Couchbase and a key part of the simplicity of our management, being able to upgrade our software versions, being able to upgrade the operating system, being able to change topologies, moving from one node with all services on it into a more scaled out 7, 10, 20 node cluster with those services segregated. Because the application is aware of the topology, you can do that without ever taking it down and without ever changing its behavior. So that's pretty much it. Just a couple more points before I hand it over to the demo team. We didn't talk too much about it, but Couchbase has cross-data center replication, whereas other technologies talk about spreading a cluster across many nodes, spread across other databases, other data centers, and geographically, Couchbase focuses on individual clusters existing in as many geographies as you want, and then linking them together with unidirectional, bidirectional, and/or filtered replication. That allows each cluster to operate independently, even if the network connection is brought down, allows each cluster to be a different size, allows each cluster to be upgraded independently, and provides for much greater flexibility in managing a geographically distributed database layer. Backups and restores are possible with Couchbase, done all online. So you can take either a full backup or incremental backups, and then restore that backup to any point, any incremental point in time, or any topology on the other end. So you don't have to restore back to the same cluster that you took the backup from. And lastly, security. So security within Couchbase, we have split out into the idea of administrative and data access security. But the concepts across them are very, very similar. So both administrative and data security has authentication. So either through LDAP, PAM, or our own built-in users are defined how you authenticate to the database. Authentication is saying I am who I say I am. Authorization, saying what my user is allowed to have access to. This is where things start to diverge a little bit. So from an administrative perspective, you want to control who can add or remove nodes to the cluster, who can view the statistics for which data set, who can create cross-data center links. From a data perspective, you're controlling who has read access, who has write access, who can perform a query, who can create indexes. And so we have a number of very granular roles that can be defined for all of the users and applications accessing Couchbase. Auditing is an important part of security. At the administrative layer, we already have an access log that allows you to audit who did what at every layer. At the application and data layer, we're working on rolling that out as well as an upcoming feature. And then finally, encryption. From an application perspective, this is about securing the APIs, providing SSL or TLS encryption to your administrative access to it, as well as securing all of the passwords, secrets, and tokens on disk. From a data perspective, this is encrypting data from the edge, over the wire, and on disk of a cluster. So this is a comprehensive security model that allows plugging into external systems, but also kind of supported within Couchbase by itself. Surprisingly, I'm right on time. So I thank you very much for giving me the opportunity to give you a very fast overview, but now I'd like to hand it off to our wonderful demo team who's going to show you some of this in action. Thank you.
Okay. Check. Thanks, Perry. Hello? Okay, perfect. You can hear me at the back? Very good. Okay. We'll just take Matt a couple of seconds to get it set up, and then we'll try and walk you through some of what some of the features look like in practice. We're going to do the demo. The demo will all be presented in English. There will be a brief French introduction. So if you don't understand French, then just hold tight, and we'll get to the English portion. If you do understand French but don't understand the introduction, that's just me. That's just my French. Okay. All right. Okay. Okay. So, bonjour, mesdames et messieurs. Je m'appelle David. Je travaille pour Couchbase à Manchester avec Paul Pogba, Zlatan. Oui. Je suis désolé, je vais parler en anglais parce que votre anglais est formidable, mon français est formidable. Je suis ici aussi pour un passeport français parce que je pense qu'après Brexit, je préférerais habiter ici, oui. Pardon. Now, le nom de la présentation est comment commencer une révolution. C'est une grande question, oui, mais nous avons une technologie puissante. Et je vais commencer avec un peu de français. J'ai appris quand j'avais 12 ans. Nous allons au supermarché. OK, encore une fois en anglais. Ladies and gentlemen. Thank you. Okay. So what we'd like to do now for about the next 30 minutes or so is take you through why we believe that Couchbase is the data platform to deliver an incredible customer experience. The following demo is all completely live, so it's going to be real data, real users, real servers, maybe a little bit of real panic. So we'll see as we go through. And so to get this done, we'd like to take you all shopping. Okay, so here's where our journey starts with a very simple e-commerce retail website. We'd like each of you to participate. So please now take out your phones, your laptops, and go to the following URL at the top of the page there. Please do this now. So that's bit.ly /CB Revolution. And hopefully you should all be taken to this page. And what we would like you to do is place an order. Matt will demonstrate how to place an order. So this is our shop. You need to type your name or perhaps your company name if you want your company to get a shout out on here. Select exactly five items, no more, no less. That's the way this shop works. And then hit submit at the bottom. So again, you show the URL again, just to make sure people have got that. So it's bit.ly /CB Revolution. Okay, and we are going to be giving away some prizes for the orders that are coming in, so feel free to make multiple purchases. You might see our shop here has a variety of items. We do have a British range with, of course, the famous British cuisine, some real delicacies, a pot noodle, a Scotch egg, and some fish fingers. So, like I say, a couple of orders. Let's see if we can see, Matt, some of these orders coming in. Okay, so we've got one here from Anil, who's gone for a burger and crisps. Ibanur, cookie, milk, again a burger. Burger's very popular today. Oh, is someone making multiple orders? Clearly a burger again. Oh. hopefully someone else will get a... Oh. We expected this. So clearly someone here has come along to see how a proper database works. Okay. So now we have some orders coming in with some traffic coming to our website. Let's see what that traffic looks like from the cluster's point of view. So here we have a representation that we've made for this demonstration of what the cluster. At the top, we have our 3 Couchbase nodes. These are running Couchbase Server 5.0, and these are virtual machines running in Amazon's Elastic Compute Cloud, AWS. Underneath, we have a representation of the visualization. So this is, again, this is all live. This is all based off the traffic, off the browsing that you're doing right now. And each of these bubbles represents one of those interactions, represents a user on our shop currently browsing. And let's just think about that for a minute, like you've heard a few times at the conference so far. What's our expectations when we're browsing? If we're on a shopping site and we're looking to make a purchase, what does that browsing behavior look like? You'll probably start by searching for the products you're looking for. You'll then read the descriptions, look at a lot of images, maybe read some of the reviews, compare the alternatives, and then make your decision. And even once you've made your decision, you might do a little bit further searching to find the best price before actually placing that transaction at the end. That's a hell of a lot of browsing in order to make that purchase. And this is exactly where Couchbase fits. So whilst we're doing that browsing, let's talk about the experience that we want each of these users to have. We want the website to be lightning fast. We want the content to be, and recommendations to be personalized and specific to us. We want the availability and the price information to be bang up to date. How frustrating when you may have seen this, when you're trying to purchase a flight, you get to that very last stage of the booking and going, okay, I've done all this browsing, I've decided, only to be told the flight that you're looking for is no longer available at that price. What a dreadful experience that is. And so you also want this experience to be as fast as possible, regardless of how busy the site is. Regardless if they've got a promotion on, if they've got a sale on. Nobody wants to see the spinner. Nobody wants the slow browsing experience. And again, this is where Couchbase fits in. So Matt, if you could now sort of generate some more traffic to the website, we'll start taking a look at how Couchbase handles this. So as you'll have probably heard today, Couchbase is trusted by some of the world's largest organizations to run their most performance-critical, important applications. Couchbase is capable of handling millions of such interactions every single second on data sets that contain billions of documents and are terabytes wide. Performance and scalability, as Perry just mentioned, is ingrained from our very core. Now, the only thing more frustrating to a user than a website that is slow or sluggish, unresponsive, is a website that's unavailable at all. This website is currently undergoing maintenance, or the browser just never brings the page back. But many of us in this room will be engineers. We understand that from time to time, things can go wrong. The disk fills up. The network goes offline. A clumsy administrator accidentally brings down the wrong server. So let's do that. Let's simulate. Let's pretend we have a clumsy administrator. And so what we're going to do is go to the Amazon Web Console and just kill one of the VMs. Just shut it down as if it'd gone down by accident. So we'll pick one of the nodes, and we're just going to forcibly stop it right now, and then flip back to that visualization to see how Couchbase handles this. OK, so you see immediately the node is detected as down. Some of the interactions that were in flight will need to be retried. And then within 5 seconds, Couchbase detects that that node has gone down and reacts. The other servers, which have replica copies of the data, respond and make that data available so the interactions continue and the users get the very best experience. Couchbase Server 5.0 has the ability to detect node failures and respond and react within 5 seconds, ensuring your customers get the very best experience. Okay. So these features, these building blocks, performance, scalability, and high availability, again, all the features we're about to demonstrate are based on these fundamentals. So let's take a look at some of these features in action, some of the features that Perry just described. Let's start with query. So you've created a bunch of orders. We have a bunch of JSON documents within Couchbase that represent these orders. How do you make use of that? How can you use the data that we've captured to generate insights into your customers and then to deliver a better experience? How would you do? So if you want to better serve your customers, be they internal or external, for example, there could be your direct end users, the people consuming your products and services, or there might be internal departments, accountancy, finance. Take our shop example. What if you want to answer questions like, which are the most popular products that our consumers are buying? It looks like burgers, maybe. Could be something else. Which items of stock do I need to replenish? What hours of the week do the people of Paris do most of their shopping? Because, hey, maybe that would be a good time to purchase my adverts. And so how would you answer these questions today? Again, maybe this means exporting your data set into a separate application that you have to install and run, administer, maintain, and generate the queries from there. Or, like I said, as we described earlier, we can use the query service within Couchbase, and the data doesn't need to go anywhere. So let's take a look at how easy it is to add the query service to Couchbase. So we're going to go to the UI. So this is the Couchbase 5.0. Those of you that have been using Couchbase before, maybe this might be unfamiliar to you. We've reskinned and refreshed the UI and made some enhancements to make managing your cluster a lot simpler for you. Adding query service only takes 3 clicks. Step 1, you provide the server credentials for the server or VM that you want to add. Step 2, you choose which services that you would like to add. And so in our case, we're going to add query and indexing service. And then step 3, hit rebalance. And that's it, you're done. 3 clicks, and now you have a powerful query language at your disposal. And so to demonstrate this is working, we're going to run a quick query now to find out if it was burgers that were the most popular product in this room. Let's see. So we're using that SQL-like language, Nickel, nest of expanding that JSON data structure, and then we're going to count them and sum them. So let's go and run the query now. Red wine. Vin Rouge. Who would have predicted the people of France would go for red wine first? Okay, very good. Oh, and in second place, beer. And third, we have the burger. So red wine, beer, and burger. Sounds like someone's planning a party this evening. Okay, so that's all very good. We've got this ad hoc query capability embedded into the UI. Let's see how we can use that to give our developers a better experience and enhance our websites. So if we run a simpler query, so now I mentioned before, all of our products that are embedded in JSON documents have a category associated with them. So we can run a simple query and select the products that match a certain category. So here we're looking for all the products that are drinks. So we should see the red wine, the beer, etc. Okay, so we can use the UI as a way of rapidly checking the queries that we'd like to then embed in our application. A nice tool for developers to be able to rapidly prototype the work and deploy. When we talk about developer agility and the faster time to go to market, this is part of the piece of that puzzle that allows you to do your application. So now if we go back to our shop, you'll see that using this query that we just ran, we can now add filters. So we can click a button and it'll show us the products in that range. So let's have a look at the British products. Now see, here are our particular delicacies. I forgot to mention beans before. Very important staple of the British diet. Okay, so quite a simple example, but hopefully that shows you the power of being able to test a query out in the UI and quickly apply it to your website. So at this point, we would like to thank one of our valued customers in the audience and see who placed the most expensive order with us. So the products that we have were all allocated a random price. I think that was it Ibanur that was who was rattling the orders in. He's probably going to have a good chance here. So what we're going to do is go back to the UI and run a slightly more complex query. This time we're going to use the SQL notion of join. So we're going to take all of the items out of your shopping basket, join them with the product documents, extracting the price, sum those, and generate a bit of a leaderboard to see who has the most expensive order. So Matt, do you want to go ahead and run that? LNT. Did anyone place an order under LNT that would like to make themselves known? No? There might be a prize involved. Okay. Next up, Ebby's next. Ebby's next. There we go. Who ordered? What did you go for? Oh, very healthy. Ham, bananas, sausages, apples, and pineapples. So we have a bottle of champagne for you, and congratulations on your order. Thank you. Maybe see you outside like a Formula One, like a Ferrari driver, spraying it around later on. Okay, very good. So that's Query, a very powerful capability that we added in just 3 clicks. And remember, the data stayed where it was. No need for a separate piece of software. No need to install to migrate your data elsewhere. And we saw how easy that was to add to the website. But come on, this is 2017. I don't want to just be able to click buttons to find my products. I want to be able to search for them, obviously. In fact, I want more. I want to be able to type the wrong thing in the search box and have the website tell me what it was I was actually thinking of searching for. And again, how would you do that today? How would you search your data? We heard just before lunch, if you saw Dave Starling's excellent session from CNET, when they were considering adding search to their product, they were considering a 12-week project to install a separate piece of software, migrate the data into that, and then run search. Again, let's see how easy it is to add search with Couchbase 5.0. But you already know the answer. It's that same 3-click process. So back to the UI, click 1, we add the server's credentials for the virtual machine or server that we want to add. Click 2, we choose the service. In this case, we're running full text search. And then click 3, we hit rebalance. And that brings the search service into the cluster. In order for us to be able to run a search, what we need to do is define an index. So this is telling the search service which set of documents, which fields within those documents that they want to be searchable, with all of the parameters, which fields, which language those fields represent, etc. So Matt's just going through the search index creation portion of the UI so that we can then run a search against our documents. So when the index is done, again, embedded directly in the UI, we should be able to check it's working. So if we search for, say, eggs, you'll see that the products, the Scotch egg and the other egg, comes up with a context-aware, highlighted indication that, OK, we've managed to find a document with egg in. Now if we go back to the UI again, you see, now we reload the web page, we have search capability at the top. So once you've got the index built, embedding it in your application is tremendously simple. So now if we search for, say, bananas, OK, and there you see the search we've taken from now the index is created. You might actually notice that Matt, poor lad, hasn't been able to spell bananas correctly. He's actually put bananas. And this is part of the power behind full text search. It understands construction of words, of natural language, stems and plurals and different endings, etc. So again, no need to move the data, no need to install a separate piece of application, a separate application. So that's query and search, 2 very powerful features that we've just been able to add without moving the data, without installing a separate application, and just 3 clicks to get started with both of them. Thank you, Matt. Okay. So let's take a look at what the cluster looks like now back in our visualizer. So if you recall, we started with 3 nodes. We went to Amazon and killed one of them. So we have 2 data nodes left running the data service. And we added 1 query node and 1 search node. So we have this 4-node cluster. Part of this ability to dynamically add servers and services to a Couchbase cluster is one of the huge benefits of running in the cloud. But saying running in the cloud is tremendously easy. You heard before Ravi tell this tale of going, hey, cloud, yeah, I want some of that. How do I do that? What about your legacy applications? What about the old applications that are already running in your data center today? And often, these older applications are exactly you choose your cloud provider, maybe Azure, maybe Google, maybe Amazon. Do you just choose your relationship and that's it? you're stuck forevermore with that cloud vendor locked in. Wouldn't it be nice to have the flexibility to move back and forth between cloud vendors? Again, how would you do that today? What we can show you is how you do it with Couchbase using cross-data center replication. So let's do it. We are, obviously, how embarrassing, we're currently running in Amazon, AWS, but here we are at Microsoft. And so we would like to thank our hosts for their hospitality and move CouchMart, move our application live across to Azure. So let's see how long it takes to move an application to a different cloud provider with Couchbase. So first thing we're going to do, we're going to go to the XDCR, the Cross Data Center Replication tab of the UI. We're going to tell the Amazon cluster about the destination cluster. We're going to tell it, give it the Azure credentials. So this is an Azure IP address that we're giving. And so that's step one. You tell the source about the destination. Okay. And then step two, again, you choose which bucket or buckets you would like to replicate to the destination. And there you go. Our documents, as we speak, your orders, your burgers are zooming from Amazon across to Azure. And now that we have done that, let's have a look at what this looks like. So currently, we have the Amazon cluster running at the top. We have the Azure cluster. So we did previously launch 5 VMs in Azure, so that they've not sprung up automatically. They were already there. But they didn't have any data, and they weren't doing anything. But they do have data now. So now that the Azure cluster is running and has our data, we can change the web application to point to the Azure cluster so users don't notice any disruption. So what we're going to do is flip the web server across to the Azure cluster. And at this point, we'll be running entirely on Azure. So we can go back to the Amazon console and switch them off. So what we're going to do now is kill all of the nodes in Amazon now that the service is running, the application is running in Azure. So Matt's just going to choose these Amazon VMs. And again, I guarantee this is all completely live. So I'm crossing my fingers ever so slightly that this all works as planned. And so those nodes are gone. And if we go back to and have a look at what the cluster looks like now, Amazon has completely gone, and we're running exclusively in Azure. And just to double check, I want to go back to the shop and make sure that we can still do our business, still place an order. This time running on Azure. Matt will choose 5 items, hit go, and the order is submitted. We were running in as Amazon. We're now running in Azure. The AWS nodes are gone without interrupting the application in less than 3 minutes. Okay. So everything you've seen so far has been with our online web application. And you've all been able to, many of you have been able to access it. But what about this? What about our mobile users? So, of course, they could have done, as many of you have done, have just accessed the site online. So you've been able to take your phone out of your pocket and order your burgers, your Vin Rouge, etc. But what about when you're not online? What if you're on the underground or the metro going home from a busy day at a conference and want to order your burger or your red wine? How do you do that if you're not connected? What about, and how does the data in your pocket reconcile itself, synchronize with the data that's in the cloud? So for the next part of the demonstration, we would like a volunteer. So please, maybe someone in the front few rows that would like to volunteer. There will be a prize involved. Do you want to, have you come? Excellent. A round of applause, please, for the volunteer. Okay. Just wait a second, we'll get you. Okay, so what we're going to do now is show you how Couchbase Mobile can be used to solve some of these problems. So we have, again, for this demonstration, we created a mobile app that we have connected here. So this is going to be running live on Matt's phone. Your name is?
Lila.
Lila. Okay, Lila. if you want to go ahead, you're going to be using the phone. And when Leela's accessing the phone there, all of the actions you'll be able to see live on the screen here. We're using a cable that's tethered there. So what we'd like Leela to do is choose exactly the same game as before. Choose 5 items from our shop and then hit submit. Leela, I will warn you that everyone's watching what you're purchasing, so choose carefully. Okay, and there we see that the order has already gone through and come live. Instantly, the data on the phone synchronized automatically by Couchbase up to the cloud. One of the great benefits of Couchbase Mobile is that we provide the synchronization code. We do that piece for you, so that's less time for you writing the synchronization code and more time writing spectacular apps. Right, yeah. Told you it was live. Well, we've got a device update. Yeah. So that's fine. The device is online, but let's increase the stakes a little bit. Let's make this a little more difficult. What if Leela is on the way home and she has no connectivity? Now we're going to simulate not having any connectivity by engaging the airplane mode of the device. So we click on the plane, and now, as you'll probably be familiar, the phone has 0 external connectivity. Now we're using a cable to connect it to the screen so you can still see what's going on, but anything that does on the phone is completely disconnected from being online. So at this point, Leela, what we'd like you to do is order 5 more items, maybe this time 5 different items. So we've gone for tea bags, water, pot noodle, milk, and eggs. I'm not sure what you're cooking, but I'm sure it's going to be very good. And have you hit submit? If we hit submit. So there we go. Leela, she's on the metro. She's ordered the food, this fantastic meal that she's going to cook later on. She's hit submit. But of course, at this point, the device isn't connected. So we won't see the order come through. That is until we go ahead and re-engage airplane mode. And as soon as Leela comes out of the metro station, comes out of the underground, and that device restores connectivity, there we go. The eggs, the milk, the pot noodle, the water, and the tea bags for Leela. Automatically synchronized, and Leela was allowed to do her business while she was offline. Okay, and so to thank you, we have an order. We have a shopping bag. And I just want to show the Leela has earned herself a pot noodle, some water, some tea bags, and some eggs. And of course, a bottle of champagne. I think she might enjoy the champagne more than the pot noodle. Okay, so that's how we can create data on the device, on the mobile, and upload it and automatically synchronize, whether or not you're online or offline. So the next bit I want to talk about is how do we update the content on the mobile device? What happens if we want to change the application data? Say we want to add some more products. We want to update Leela on her order, which is delivered. Maybe we want to tell Leela about a special offer we've got on pot noodles this week. How difficult or how easy is it to update the data on the mobile? So in order to do this, what we're going to do is go back to that same query editor that we saw before. This time you might notice at the top, this is the cluster that's obviously now running in Azure. And what we're going to do is we're going to simulate one of the effects of Brexit. So unfortunately, the bad news, or maybe good news, once Brexit occurs, some of that fine British produce, the pot noodles, the fish fingers, will be harder to acquire on these shores. So what we're going to do is run a query. This time the query is going to update some of the documents, those product documents, where the category is British, and we're going to set the stock price, the stock level to 0. And so if we look for some of the British products on the mobile, Marmite, pot noodle, Scotch eggs, etc., when we run that query, so this is changing the data live on the server, and what we notice immediately, the products, the mobile experience has changed for the user. That's a simple SQL query. A simple SQL query on a single management platform automatically synchronized the data in the cloud to the data in the pocket. Nobody else can do that. Okay. So that brings an end to the demonstration. A recap of what you've seen. We started with a simple web application. We added query and search in just 3 clicks to get going without moving the data, without installing a separate application. We moved cloud providers from AWS to Azure. We showed you mobile, synchronizing online and offline, and how easy it was to update the device on the mobile using a simple SQL-style query on the cloud. That is why we believe that Couchbase is the data platform to transform your customer engagement. And that is how you start a revolution. Merci.
Wasn't that a fantastic demo? I mean, sometimes you don't realize, how heavy a lift these guys showed in terms of how quickly the transformations happen, right? I mean, nodes coming down, nodes coming up, new services being invoked, moving from a cloud provider to another. These are, if you put a dollar value to some of the stuff that he showed, millions of dollars saved. Otherwise, these are projects that people execute over years and months, and with the kind of support or an army of people standing behind here, 3 guys or 2 standing and clicking around in the UI, and magic happens. So I think to showcase that, sometimes we ourselves don't realize the power of what is available, and what Dave and Matt showed is very inspiring even for me. So thank you, gentlemen. So with that, questions, shoot away. I don't have anything prepared to talk to you about. I've done my bit for the day. So if you have questions, we got going. Please.
You introduced some time ago the full text search capability. Do you officially pretend to be credible concurrent or substitute to more famous search engine like Solar or Elasticsearch?
The question is, you introduced full text search. Are you a pretender? Are you a contender? Are you a legitimate full text search provider? The answer is we are not directly, in one sense, functionally equivalent from the standpoint of a full search engine. The thing with the search engine is that typically your job out there is to go look beyond JSON. So that's about finding any kind of document and being able to find the text inside it. That's what a search engine is supposed to do. What we have done here is, at this point, limited this to just look within JSON and find the power. The JSON, what you have to realize is a human readable document. So you can look inside that as though it's a Word document and do find, in which case it should be able to find the tokens anywhere inside the document. At the same time, JSON is a document which has got the schema inside it. So you should be able to do structured query in it, which is what David was showing a lot of it in terms of inventory, in terms of the types of food, British versus non, and all that stuff. Those are all structured query. Yet at the same time, you can search for banana and it could be sitting anywhere. It could be a comment, it could be in the order item type, anywhere. So that's where a search comes into play. So what we are doing with full text search is to be able for you to look inside a JSON in a structured manner with our nickel and introduce to that this unstructured querying or token-based querying. So this is what is called information retrieval, where you can look for a token like run, and ran and running, in other words, it's a natural language processing part of it, because it's the whole idea of search is to find meaning. It's called information retrieval. The query side is data retrieval. So what you do for that is you create an inverted index, which is doing the frequency counting and stemming and lexical analyzation. Whole pipeline is sitting behind it. That's what we've introduced. To to answer your question in a short manner, it's not exactly a functional equivalence for a Elastic up to a point, but there are a lot of similarities. And though Elastic can only do like a sort of a search type thing, in our system you can do both a structured query and a semi-structured or tokenized search. Does that clarify? Pretty long-winded way of saying that yes and no. Please, his hand came up just a microsecond before you. We are very sensitive to performance here.
Just to follow the full text search thing, in Elasticsearch you have the possibility to have plugins to enhance the NLP processors.
Yes.
And stuff like that.
Yes.
Do you plan to do something similar?
We have just started to crawl. So when we walk, we will add some of those plugins and stuff. You will need some of those because, as you can imagine, you can do a lot of stuff with search in terms of plugins. You can do domain-oriented plugins. You can do language-oriented plugins. A lot of stuff is available there. We will. That's the architecture is there in terms of what we build and how we support. We are a little bit away from there, but we will get there. Your turn.
Elaborate a little bit on the legacy of, because document databases are not new. So there was
Mhm.
document databases before.
Mhm.
Go back to Domino.
Mhm.
You can go to Couchbase, you can go to Couchbase, then Memcache comes in, you
Mhm.
build them together.
Mhm.
You add footage index, then you add analytics.
Mhm.
What is the natural evolution of building a stack on Couchbase? I mean, are you going to add applications later? Where does it end, or should it end?
No, the thing basically is, should it end? Yes, at some point. And where should it end? That we will leave to the customers and users, but it cannot just forever be going. But the point is that monolithic stacks and monolithic applications have their own sort of limitations. Where the layers have to consolidate, they haven't. Where they are sort of should is what we are trying to achieve this year. Because if you really look, I use a simple example like an iPhone to demonstrate this. It's about 40 devices into one. So what happens? The cost of those 40 devices, if you bought separately, is like 10 times the cost of buying this iPhone. So the cost becomes cheaper, performance is faster, usability is way better. So that's what happens when you consolidate a set of technologies in tiers and bring them to one. We believe in this sort of a database which is interaction-oriented or engagement-oriented thing. You need a few technologies to fuse, and the value comes from there. We cannot just leave it like a regular database and do query here and create another search system and leave it there and create another analytics system. So there is a data pipeline that is behind, which is basically you start with using the system which is capturing, and then you query, then you search, then you do start to do some reporting, then it goes into the analytics side of it, and then you do recommend. That's the sort of operational analytics side of it, after which you can take this data to your data lakes, where you want to mix this data with other systems and find like complex event processing or complex pattern matching, if you will. So this event pipeline of a data is basically for us to provide that value to end user experience in collapsing times, basically. Because you have a search and a database in the same system, you don't have to create another connector to move this data. So the data is fresh when you search for it, and the information is consistent. And analytics, the same way, if you do it, then your time to insight should become seconds. What now takes in multiple instances, days even, if not hours. Because what you end up doing is that move this data to a, let's say, Hadoop or analytics system, which is a different programming model, and you batch it, move it there, do your intelligence gathering from there, and then push the data back into Couchbase. This is what we see many customers do. So we want to avoid that whole pipeline, having to learn two different programming models, move the data from one system to the other. If it's all in the same system, then you can find the insight within tens of seconds, or maybe even sub-second, depending upon the scale and size and stuff like that. So that's where the value is. So if you don't do this, what happens is that today you may be looking for something. Tomorrow, advertisers will tell you about, let's say you're looking for shoes today. Tomorrow you'll get recommendations for shoes on your browser, and you're like, why are they stalking me? The reason is they couldn't find that insight in time for you when you were really looking for shoes. And if you do that, that's when the value proposition begins. It's not about reporting that side of the equation. It's about being able to pipeline this data back into the application where you find. And you have to fuse these systems because you can, but more than that, because JSON is the document data model that we have chosen, which is human readable. And you have to take advantage of that. That's when you apply a natural language processing sort of techniques to it, you will find information out of it. Because prior to this, relational systems and all, there was no format. It was some binary representation of data internally. When you're getting this data in a format that is human readable and consumable, make use of that. At the same time, it's also sort of shipping you the schema every time. Make use of that as well. And the natural evolution of it is eventually get to the analytics, finding the insight side. And you asked the question about, do you go into the application space? Well, serverless programming is the next thing. So bring more logic closer to the data is always the way. So we will not perhaps take that on in the current manner that people think, but generally you have to introduce sort of eventing sort of techniques into the database tier, which will allow you to use old terminologies. It's triggers and stored procedures. But if I were to really do the marketing spin on this, that's your Lambda. So you can do your reactive programming. When the data walks in, you fire your logic and take action based on that. And that can be streamed out, piped, synced, operated upon, anything that you want to transform the data. You can do it in a sort of reactive programming manner. So we will build up to that point, keeping the edge to be on the server side. And the rest, because people have made investments in terms of what the application stack ought to be, and which could be Java or .NET or wherever. So we have to be careful in terms of sort of adhering to those and plugging into those and not subsume it. Questions? More?
Hold on.
Please.
Dave.
How do you see the growth of containerization in especially the cloud landscape as being relevant to the database landscape, especially in regards to scale and security and deployment capabilities and operational management?
That's a way of the future. We still believe a good chunk of the databases will perhaps be still run on bare metal. That's because they are very performance sensitive. But more and more of this stuff will happen in a containerized environment. And so far, the general evolution of containerization is based on this notion of stateless systems. So you can very easily scale or burst stateless systems, and that you can do with containerization technologies. The moment statefulness comes into it, containers are not in the best of shape so far. That's because there's sheer physics involved. When you're stateless, you can build everything stateless in the world except the database, because that's the one that maintains the state and gives meaning to all those stateless systems. When they come and discover themselves, where do they find their information about what should they be doing? That comes from a database. So now the database end of the world job is basically physics of moving the data in a reliable manner. But to do this in a container in a stateful manner is the difficult part right now. And there are stateful sets, sort of a concept that containers are introducing into this. And it's an orchestration tier as well as a container tier. Boundaries are there, which we want to make sure that they are in good shape before sort of standing behind that fully from a Couchbase perspective. People are running it right now. We are good. But when certain data volumes for certain sort of failure scenarios and recovery scenarios, it's not as robust as it should be. But it is getting there, and we are watching it. We are working with it. But we will definitely introduce that if things go well, maybe even next year kind of stuff. So it is the way of the future. And we want to be deployment model agnostic, which is it could be bare metal, it could be container, it could be cloud A, B, C. That's where we should be, because we should naturally plug into where people are running their applications. You cannot expect people to move their applications to where the database is running. That's my hope. So we should naturally plug into the places where people will be running their applications and We should seamlessly and very easily be able to deploy, manage, upgrade, monitor, and the full life cycle of a database to be addressed in a containerized environment is the vision. The rest of the technologies have to be there. And as you know, there have been multiple stacks, OpenStack, not so OpenStack, Kubernetes, Mesosphere. That has to sort itself out a little bit too, because we can't spread ourselves thin by looking at the whole universe. But Kubernetes seems to be, I don't know what is the tier above that, which is going to win, but because each cloud platform has its own thing, and there are Terraforms, other stuff coming over there. But Kubernetes at least is the orchestration tier sort of leader. Perhaps with the kind of support, even guys like Mesosphere are actually supporting Kubernetes now more than their own proprietary ones. So we will continue to sort of innovate on that space. One last question, perhaps, because she's saying I'm already over the time. So, one right there, he's standing.
Can you talk a little bit about Couchbase Mobile and what's coming and where you see or how you see the mobile landscape changing from mobile 1.4 to I know 2's coming out. And I've heard there's a lot of different performance things in there, and with Sync Gateway, especially it's using MapReduce. Is that going to be changed to use like GSI or take advantage of Plasma?
Yes.
Or things like that are coming?
Yes, definitely. Where is Wayne? He can answer some other stuff, but let me answer to the extent I can. That's generally the plan. We want to introduce a lot more functional capabilities as well, like search and nickel equivalents on the edge, on the device as well, so it's easy to program to. But beyond that, we definitely are we will be working on exactly the points you raised about our indexes that are built on Sync Gateway, our old views-based indexes. We want to move that to GSI and nickel oriented. So that should speed up a lot of stuff on that front, both scalability-wise as well as availability-wise. So that you should definitely expect in the near future. But beyond that, there are a lot of innovation to be done on the sync as well as the light database, to the extent that we want to even explore what is beyond the device. The edge is getting more and more edgier. So what should be, is there a smaller form factor that we need to be fitting in? And that's exploratory right now, but we are thinking beyond just what you would consider an edge right now, which is a device. The device form factor could be even smaller, micros and minis and whatnot. So we will innovate on that front. Idea is to move data as close to where the action is, and bring as less data as possible to the cloud, because you want to find the information there and push it back. Otherwise, mobile strategy is flawed if you're going to move all the data from the edge to the cloud and then do something there. Your job should be to filter out the data that is noise, because if a signal, if a sensor, all the sensor is going to do is every second or so wake up and say I'm alive. If it doesn't do at the right interval, that's the signal, which is to say somehow it is not saying I'm alive after the 1 second interval. That is the information that pattern is what needs to go up to the server. So the filtering that out from all the way to the edge to the cloud is where the rest of the magic is. So that's where all the innovation would be. Fantastic, people. There's one hand coming up. Okay, let me see if I can address this one in 1 minute and we'll wrap it up. Wait for a second. She's making all the effort.
So something I've been thinking about since morning is that I get the idea that we're trying to completely work off of the memory, trying to keep as much data as we can in the memory. It's faster to query, faster to everything. But I see a scenario where the amount of data coming in might be higher than the rate at which we can persist it to the disk. Mm-hmm. This is especially, we're talking about Docker containerization and putting stuff on the cloud, and mm-hmm. especially on the cloud, you can't be sure what kind of storage solution they have. It could be a networked storage solution. It could be, if you're bare metal, you have your own hard disk and stuff. But the servers could be several. Mm-hmm. So the amount of data coming into my Couchbase cluster could be infinite, mm-hmm. theoretically. but the rate at which you can write it to disk is not. You're smiling, so you've thought about it. So, of course. But my question is two-pronged. One is, as a systems engineer, I'm not able to think of a solution to this. I'm not even sure if it's solvable. As an application engineer, my question is, how do I protect my application from this kind of an edge case scenario? What do you propose?
So as far as the infinite capacity of stuff coming in thing, it's a question of how you set up your system, so to say. But the biggest benefit of having a horizontally scalable system like this is that you daisy chain more capacity, and that's how you can get, we have customers sort of who are doing 8 million ops per second kind of stuff. So imagine the kind of processing and the kind of data that is coming in. The second is, in terms of storing it on disk, is slow, agreed. That's why we are a memory first architecture. We will persist it eventually onto the disk. You don't have to worry about it. You don't have to wait for it. That's what happens in traditional databases, that it has to hit the disk before you actually get. Here you don't. You have further sort of late binding principles where you can leave the system to manage it, or wait until it hits the disk, or wait until it is replicated. So these days the progress is so much on the network front that accessing that memory across the network is faster than hitting the disk, right? So that way you can scale. You can scale horizontally by adding more capacity and daisy chaining, and if you have the right network bandwidth behind it, then you will infinitely scale, right? So that is the first thing. Disk is necessary because persistence sort of comes from there. There also there are enough advances, SSDs and stuff like that, so the drain rates into the disks are also advancing tremendously. So at this point, with the sort of innovation, there is non-volatile memory coming. So you're not even worry about the fact that you'd hit the disk, because even if you switch off, the stuff remains in memory. So we work with Intel in terms of the advances that are happening over there. So world is changing. The sort of assumptions or the sort of theories we are taught in schools are also changing now. But if you think disk, I don't have a timeline, but pretty quickly disks will be showing up in computer history museums, right?
But
So
my budget is still limited, so I can't afford.
true, the
all of that.
cost will also come down, right?
So how do I? Okay, I got it. How do I protect my application from a scenario like this? How do I detect that Couchbase my cluster might be struggling with the disk I have in place currently, and what software? Maybe I should come to you after.
Yeah, you can. But basically, it's about, like I said, application needs to be split in such a fashion that you can infinitely scale. That's how you architect it. So you can. It's a problem that has been solved, but it's a problem that will continue to get solved based on people's needs. So modern architectures help you for this infinite capacity and how to scale it. Thank you, everybody. You can always find me with any of your really esoteric questions which you don't want to ask in front of everybody.